Okay, so today we're going to be working on Snell's Law Practical. What we're going to do is we're going to use some projector, plastic rectangular blocks and a ray box, as well as, the power packs to charge the ray box and some calculators. So what we're going to do is we're going to place this rectangular shaped plastic perspex in the center of this A3 paper and chase around it. Then we're going to highlight the bottom line as well as the top line. So we're going to chase this line a little bit more. Okay, and what we're going to do now is we're going to try to find the normal. So by drawing a perpendicular line to the baseline, that's how we're going to find out normal, and we're going to place our projector in the center so that we can see where is 0, where is 20 degrees, and where is 40 degrees. We're going to mark them out, and we're going to now put this block back into the center, and we're going to shine the ray box through this block at an angle of 20 degrees, which we call it as the angle of incident. And we're going to mark the line where the light comes out of, as well as for 40 degrees. And we're going to do the same thing. We're going to mark the line. Okay. We're going to extend our normal a little bit longer so that we can measure the angle of the refraction for 20 degrees as well as 40 degrees. So it's roughly around 14 degrees as well as around 24 degrees here. So we're going to draw that line to our center at the bottom. Extend the line again. Okay. So this is our angle of incident and this is our angle of refraction. And that's our normal again. So zooming it in so that you can see it better. And now we're going to test it out with the Snell's Law formula to see if we got similar or data that's close to what the calculation is going to tell us. So obviously we have our angle of incident at 20 degrees. And our first medium, which is the air, is 1.0. The refractive index is 1.0. And the refractive index for perspex is 1.5. And we're going to calculate our first angle of refraction. So we're going to use sin I over sin R equals to N2 over N1. N2 is 1.5, which is the refractive index of our perspex. And N1 is 1.0, which is the refractive index of the air. And we have sin 20 degrees over sin R equals to 1.5 over 1.0. Cross multiply, we're going to reformulate this. So we have sin R on the left-hand side as the subject equals to sin 20 times 1.0 over 1.5. And we're going to find the angle by reformulating sin. So shift sin bracket equals sin 20 times 1.0 over 1.5, close the bracket, and we see the angle is around 13.18. So based on Snell's law, the calculations show us that when we have an angle of incident at 20, our angle of refraction will be 13.18 degrees. So we're not too far from what we measured. And we're going to test it out again for the second angle of refraction. So this time our angle of incident is 40 degrees. N1 and N2 stays the same, which is the air, and the plastic block, which is 1.0 and 1.5. And we're going to calculate the angle of refraction. Use the same formula again. We have sin 40 degrees over sin R equals to 1.5 over 1.0. And sin R times 1.5 equals to sin 40 times 1.0. So therefore, we're going to reformulate this just like how we reformulate the first equation on the right-hand side. So we have R equals to inverted sin, bracket equals to sin 40 times 1 over 1.5, and then we're going to close that bracket. So we're going to do the same thing again on our calculator, which you will get 25.37 degrees. So we're very close to what we estimated before through measurement.